Chapter 71, solving formulas involving quadratics. Remember that if ax squared plus bx plus c equals 0, then x is b squared minus 4ac. This is not quite right. This should be negative b plus or minus the square root of b squared minus 4ac over 2a. As an example, okay, I don't know where that came from. If v is pi r squared h, solve for r. Well, first, h is treated as a constant, v is treated as a constant. So we divide by the constant, pi h, and then we take the square root. And then, if r is radius, obviously it cannot be negative, so we reject that solution. Then, if f is g, m sub 1, m sub 2 over d squared, solve for d. First thing we do, we multiply by d squared, we divide by f, and we take the square root. This one, solve for v. So, okay, we have the square root here. What did we have originally? I'm copying the equation. Then I am squaring both sides to get rid of the square root. Then I am multiplying by the denominator. I'm dividing by m squared. My object is to isolate v squared. So I multiply by c squared. And the fraction drops out over here. Remember, I'm after v, so leave the fraction the way it is. And what do I do next? I subtract this quantity from both sides, and I add v squared. And finally, I take the square root of v, and I get v. Again, plus or minus, but again, the minus is probably not a solution here. And then solve for b. B is your unknown. A squared and c squared are some known constants. So subtract a squared from both sides and take the square root. Another example, you want to solve for c. Oh, this looks like quantity squared, quantity, and a constant which is equal to 0. So this is a. This is b. A is m sub 0 squared, b is p squared, and c is minus e squared. In the quadratic formula, we plug in. We have negative b, which means negative p squared, plus or minus p squared, quantity squared, minus 4 times a, where a is m sub 0 squared, times c, which is negative e squared. And when we crank it out, we have a square root here. We get another square root if I get c by itself. So I got square root of square root, which I guess you have to live with.